Hey guys, welcome to our final week of distance learning, your final week of watching lots of YouTube videos to learn your college trig. It is all coming to an end. Today we're going to go ahead and move on to section 6.4. We're continuing our study of vectors, and today we will add a new concept called the dot product. So without further ado, let's get her started. So far, you have studied two vector operations. Vector addition, and remember this also includes subtraction because subtraction is addition of the opposite. So when they say vector addition, that means you can add and subtract vectors. And we did multiplication by a scalar. So remember, a scalar is a single number that you can distribute into that component form of a vector. Each of those operations yields another vector. So if you add or subtract vectors, if you multiply by a scalar, your solution is another vector. Okay, but in this section, we're going to look at a third vector operation, and that is called the dot product. And the dot product is unique because you end up with a scalar, meaning a single number, instead of a vector. So your final answer is just going to be a number. Here is the formula for how to find a dot product. So if I want to find the dot product of u and v, and notice they just use a dot right there. The formula says you're going to take the x value from vector u times the x value from vector v. So you will take the two x's, multiply them together, plus the y value from vector u times the y value from vector v. So again, you'll multiply those, add the two products, and that will be your final solution. So without further ado, let's go for it, guys. Let's do 3 of these just to see how they work. So this is the dot product. The x component from the first vector is 4 times the x component from the second one is 2. Now I look at the y values. 5 times 3. Order of operations, you multiply before you add. 4 times 2 is 8. 5 times 3 is 15. 8 plus 15 is 23. That is your dot product. So again, notice you're not ending in a vector. You're ending with a single number, a scalar. So let's go ahead and look at this one. The x value from the first vector is 2 times the x value from the second vector, that's a 1, plus the y values, negative 1 times 2. 2 times 1 is 2, plus negative 1 times 2 is negative 2. 2 plus a negative 2 is 0. So notice it is possible for your dot product to be positive. It's also possible for your dot product to be a 0. Last one. The x value is a 0 times our second x value, which is a 4, plus 3 times negative 2. So I have 0 plus negative 6. 0 plus a negative 6 is negative 6. So just from these 3 examples, you can see that your dot product, you can have positives, you can have negatives, you can have 0. It says be sure the dot product of two vectors is a scalar. It's a real number, not another vector. As we saw above, your dot product can be positive, negative, or 0. Now, this is really cool. So all of those properties that we have dealt with in math for years, they also work with the dot product. You can see the commutative property. It doesn't matter if you take u times v or v times u, you'll get the same answer. If you multiply by a 0, you get a 0. This is distributing. The u goes to the v and then the u goes to the w. If you take v times v, that is the magnitude squared. So this is an important one as we move forward. If you take a vector times itself, what you get is the magnitude of the vector squared. So here's a cool thing. If you want to find the magnitude of a vector, take it times itself. And then in order to solve for the magnitude, you'd have to take the square root of each side. And we will go ahead and do this on the back side of this worksheet. All right, let's go ahead and combine all of these different properties and operations that we've done so far. So this right here means dot product. You always do what's in the parentheses first. So if I am looking at u and v, okay, dot product, negative 1 times 2 plus 3 times negative 4. Negative 1 times 2 is negative 2 plus 3 times negative 4 is negative 12. Negative 2 plus a negative 12 is a negative 14. So that's what this is. So we have negative 14 times W. Now W is a vector, 1, negative 2. This is a scalar. Because it's one number and you're multiplying it by a vector, you can distribute that. So it's taking all of these ideas and bringing them together. Negative 14 times 1 is negative 14. Negative 14 times negative 2 is a positive 28, and you're done. Okay, now looking at this one. You're finding the dot product of u times 2v. So what I do is I say, okay, I have u the way that it is, and I want the dot product with 2v. So if I take the v component and I distribute a 2, because that's a scalar multiple, 2 times 2 is 4. Negative 4 times 2 is negative 8. So I already took care of 2 times v. Now I just have to find the dot product. Negative 1 times 4, because I'm multiplying the x components together, plus 3 times negative 8, multiplying the y components together. Negative 4 plus negative 24 is a negative 28. So one thing I wanted to point out, that when you are combining your operations, there are times where your final answer will be a vector, that component form, and there are times where your final answer will just be a single number. So it is possible to have either of these things occur. Okay, let's go ahead. The next one, dot product of v and w. So I'm taking the dot product of these two vectors. The x value 2 times the x value 1, plus negative 4 times negative 2. 2 times 1 is 2, plus negative 4 times negative 2 is 8. 2 plus 8 is 10. So there was another problem where our solution is just a single number. You always do the dot product first, or whatever's in parentheses. Okay, this is in parentheses, so I'm taking u, which is negative 1, 3. I'm going to find the dot product with 2 times v. 2 times 2 is 4. 2 times negative 4 is negative 8. So I'm finding this value first. Negative 1 times 4, because I'm multiplying the x components, plus 3 times negative 8. Negative 1 times 4 is negative 4. 3 times negative 8 is negative 24. Negative 4 plus a negative 24 is negative 28. So that's what this is. So we have negative 28 times w. Now w is the component form of a vector. It is 1 and negative 2. So in order to multiply those, this is a scalar multiple. You're going to go ahead and distribute that in. Negative 28 times 1 is a negative 28. Negative times a negative is a positive. 28 times 2 is 56. So that is the first part of 6.4. Now we're going to go ahead and look at this formula. So here's the formula. As we go to the back side, I want to make sure we've got it. If you take two vectors and you multiply them by themselves, so if I take v times itself, what the result is the magnitude of v squared. Okay, so let's go ahead and look at this. It says the dot product, so u with itself. So u times u is 5. So u times u would be the magnitude of u squared. So we know the magnitude of u squared is 5. If I want to find the magnitude, what I have to do is cancel the power of 2. Square root cancels a square. You cannot have a negative length. So in this case, you do not include both the positive and negative. It is just the square root of 5. Super cool. Okay, so this one, they gave you the setup. Now this time, they're going to give you a vector for u, that component form. Use the dot product to find the magnitude. So that is this formula. So I have to take u times itself. Okay, so I'm finding the dot product. The x components are both 2, plus the y components are both negative 4. 2 times 2 is 4. Negative 4 times a negative 4 is a positive 16. 4 plus 16 is 20. So that's what the value is. So 20 is equal to the magnitude of u squared. Because whatever the dot product is, if you multiply a vector by itself, whatever that is, that's equal to the magnitude squared. If you're trying to find the magnitude, you simply take the square root. Because the square root cancels the square. 20 is not perfect, but I can break it down. It's 4 times 5. 4 is 2 times 2. So the magnitude is 2 square roots of 5 because I can cancel 2 2's, cross off 2 2's. That allows me to write 1. That 5 is stuck underneath. Let's look at one more of these. Now remember, this is called a linear combination. This just means that the 6 is your x component. The negative 10 is your y component. So this is the same thing as saying u 6 comma negative 10. These two things are interchangeable, okay? So if I want to use the linear combination, for me, I immediately go into this format first because I know that they're the same thing, and why learn how to do a process two different ways when you can just convert it, okay? We want to determine the magnitude. So you have to multiply, do the dot product of vector u with itself. 6 times 6 is 36 plus negative 10 times negative 10 is 100. So it's 136. And based off of the formula, whatever you get when you multiply a vector by itself using the idea of the dot product, that is equal to the magnitude squared. So if I want to find the magnitude, I need to cancel the power of 2. 136, well, that's 4 times 34. 4 is 2 times 2. 34 is 2 times 17. So I can cross off 2 2's. I get to write a 2. 2 and 17 are stuck. 2 times 17 makes 34. So these three examples really showed you how this property works and how you can actually use a dot product to find a magnitude. So again, just gives us another tool for our toolbox. Rather than always having to go to the idea of the distance formula, we can go ahead and use dot products. Okay, last idea for the day. You can find the angle between two vectors. So check this out. So here are two vectors, right? So it's going from here to here and it's going from here to here. I can find this angle using this formula. Okay, but here's the space that I skipped, the angle between. It only works to find an angle between two vectors. And the vectors have to be non-zero, because remember, a zero vector means that you have no length. The initial point and the terminal point are at the same spot. So that zero vector was like, there's a spot, there it is, okay? You can't have an angle in between that. So it has to be non-zero vector. Here I wrote over mine, but this is showing you that your angle has to be between 0 and pi. So we have to go in between and including 0 and 180 degrees, because they say it has to be between 0 and pi. So degrees or radians, however you want to work with it, just make sure that your calculator is matching how you want to calculate your angle, okay? The angle can be found using dot product. So here you go. It is the cosine of theta. So we will be canceling a cosine using an inverse. You do the dot product of the two vectors that the angle is in between over, now you have to find the magnitude of u and the magnitude of v, and you just multiply those. This is not a dot product. This is multiply the magnitudes, that's the bottom. The dot product goes on the top. So let's go ahead and find this. I typically start off by finding the magnitude. Not sure why, it's just a Mrs. Becker thing. Okay, so if I want to find the magnitude of u, because that is in the formula, distance formula, but this is component form. So I can go ahead and take 4 squared plus 3 squared. 4 squared is 16, plus 3 squared is 9. 16 plus 9 is 25. The square root of 25 is 5. So the magnitude, the length of vector u is 5 units. The magnitude of v. This is component form, so I can just square the two components and add them together. 3 squared plus 5 squared. Well, 3 squared is 9. 5 squared is 25. 9 plus 25 is 34. I can't simplify that because 34 is created by taking 2 times 17, and I would not have any pairs of numbers. Now I find the dot product because that's what the numerator is. So if I take the x component times the x component, 4 times 3 is 12, plus y component times the y component, 3 times 5 is 15. The dot product is 27. So the reason why I do this, I think that it's going to make more sense if we just find each individual element first. Now we can fill them in. So the cosine of theta equals the dot product was 27 over, if you multiply the two magnitudes, it's 5 square roots of 34. Now I can't simplify this at all. Don't worry about rationalizing the denominator because this is not your final answer. Your final answer is what is theta, okay? But if you could simplify something, you would want to because it'd make it easier. In this case, I can't. So I'm going to go ahead and take the inverse cosine of each side because that's what theta is. Now here you're going to have to be really careful entering this in your calculator. I'm going to use degree mode because that way I know my angle has to be in between 0 and 180. So it's the inverse cosine. It will open a parenthesis. Now this is where you got to be careful. It's 27 divided by. This has to be in parentheses as well because otherwise what's going to happen is it will take 27 divided by 5, then take that quotient times the square root of 34. This is a product that has to be done before you divide. So you do need a separate set of parentheses. So this is what you would enter into the calculator. Let's go ahead. I'm going to make sure I'm in degree mode. Awesome. Second cosine or inverse cosine, 27 divided by. Now the bottom is 5 square roots of 34. I get 22.17. So theta is 22.17. That is the measurement of the angle that you would be able to find in between these two vectors. Yes, 22.17 is in between 0 and 180, so it matches what they're telling us our limitation is. Let's do 2 more of these and call it a day, guys. Find the angle between U and V. So again, I like to start off by finding the magnitude. This is in component form, so I can take each component squared, add them together, that's underneath the square root. So again, this is that distance formula. 4 squared is 16, plus 4 squared is 16. 16 plus 16 is 32. Well, 32 is 16 times 2. 16 is 4 times 4. So I can cross off 2 4s, put a 4 on the outside, 2 is stuck. So the magnitude, the length of vector U is 4 square roots of 2. Now, let's find the magnitude of V. Again, it's in that component form. So negative 2 squared plus 0 squared. Negative 2 squared is 4, plus 0 squared is 0. 4 plus 0 is 4. The square root of 4 is 2. So now I know the 2 elements needed in the denominator. Now I'm going to find the dot product. So if I take U times V, multiply the x components, plus multiply the y components. 4 times negative 2 is negative 8. 4 times 0 is 0. Negative 8 plus 0 is negative 8. So I have the dot product, I have the 2 magnitudes. Now let's go ahead, and I ran out of room, so I'm just going to grab a separate sheet of paper here. Let's put it all together and solve for theta. So the cosine of theta equals the dot product, negative 8, over, now if you multiply these two, outside numbers get multiplied with outside numbers. So 4 times 2 is 8 square roots of 2. I can simplify this, you guys. So I have the cosine of theta, the 8's cancel, so it's negative 1 over square root of 2. Now again, don't worry about rationalizing the denominator because this isn't your final answer. I need to cancel the cosine, so I take the inverse cosine. So theta equals the inverse cosine, it will open a parenthesis, negative 1 divided by the square root of 2. Let's go ahead and see what that is. Inverse cosine, negative 1 divided by the square root of 2. I got 135. So theta is 135 degrees. If you were to draw out those two vectors, the angle that would be in between them would have a measurement of 135 degrees. Again, 135 falls between their domain of 0 to 180, so we're good to go. One more question. What happens if they give you the linear combination? Well, just keep in mind that it's the same thing as component form. So if I have 2i minus 3j, that's the same thing as 2 and negative 3. The I is the x value, the j is the y value. So here, there's 1x, because that's the same as 1i, and minus 2j. Now it's the same thing. So it is the exact same idea. You just still have to be confident and comfortable going from that linear form to the component form. Now if I find the magnitude of u, it's in component form, so I can take 2 squared plus negative 3 squared underneath the radical. 2 squared is 4, negative 3 squared is 9, 4 plus 9 is 13. Magnitude of v, 1 squared plus negative 2 squared. Well, 1 squared is 1, plus negative 2 squared is 4. 1 plus 4 is 5. These are the two magnitudes. I can't simplify either of them. Both of them are prime values. Now I need the dot product, u and v. Dot product between u and v. Multiply the x components, 2 times 1, plus multiply the y components, negative 3 times negative 2. 2 plus negative times a negative is a positive. 3 times 2 is 6. So 2 plus 6 is 8. So the last thing is we're going to put all of that information together and solve for the angle. Let's do this. Awesome. Okay. The formula to find the angle between two vectors. The cosine of the angle equals the dot product on the top. That's 8. Multiply the two magnitudes together. Both of these values are inside of a radical, so you multiply. It's inside times inside. 13 times 5 is 65. Again, I can't simplify this because if I were to break it down, I'd have 5 and 13. Don't worry about rationalizing the denominator. We are solving for theta. So I have to do the inverse cosine. So theta equals the inverse cosine, 8 divided by the square root of 65. So inverse cosine, 8 divided by the square root of 65, and we have, wow, that's a little angle, you guys. Theta is 7.13 if I round it to the 100th degrees. So that's a very acute angle. It's very little. Okay, so, but it still follows. It is in between 0 and 180. So your suggested assignment, if you need extra practice with the dot products, or finding that angle in between two vectors, or using dot products to identify magnitude. There are some good questions in the book, 1 to 21. Again, I just said the odds. That way you can always check your answers in the back and make sure you're on the right track. But that is it for 6.4. Tomorrow we are going to go ahead and do what I call Vectors 101. You've learned quite a few things about vectors, and I do think it will be beneficial for us to take a day and just review all of it, kind of put it together and look at our wonderful world of vectors. I hope you guys are having a great day and celebrate. This is our last week. I'm proud of you, and I'll see you tomorrow. Bye.